Okay, everyone, we are back for part three of the lecture for confidence intervals or for estimation procedures, excuse me. We are back for part three. Um, and in this particular part, like I said before, I will go through and show you stuff related to proportions. Now, when it comes to proportions, confidence intervals for proportions, you know, again, we obviously have the ability to do it. We have the ability to conduct procedures, estimation procedures with proportions. These procedures are similar to those that use sample means, but not completely the same. One thing that is the case, the sample does have to be large. So for sample proportions, the sample itself has to be large. So the sample must be greater than or equal to 100. Okay. The sample must be greater than or equal to 100. I think in some of the stuff I have further on down, and maybe even the book, I think it says, it just says greater than, but basically greater than or equal to 100. So these are just basically the steps. You follow some of the same steps that you follow for the other confidence intervals. It's just that the way we calculate these, may be a little bit different. All right, so let me get the highlighter, and I think I want to change the color. Okay, so as you can see, the formula differs, and I'll walk through some of that stuff in just a minute. But what you have here is the sample proportion. That's what this is. You still have a z-score. You still have the number for the sample. But this stuff right up here, you know how in the previous one we talked about sample standard deviations and population standard deviations? Well, this is one of the bigger changes, if you will, okay? But as you see, when I go through the problem, you'll see what I'm talking about. All right, so again, note that the formula for the standard error includes the population value that we don't know and we're trying to estimate. That's part of what we're trying to get to with this type of a problem. So what ends up happening is the sample proportion ends up, or excuse me, the sample proportion, the standard error part ends up being equal to, or the proportion ends up being equal to 0.5, excuse me. The proportion itself ends up being equal to 0.5. So that, they do all this stuff and there's all this technical stuff that I'm not gonna go into in terms of how they get to this information right here, okay? Because if you remember, or if you think back, let's look back, this is the formula for the top part, the numerator portion of the part for the standard error. This is normally in this, I keep moving. Okay, I promise I will stop moving this. And this part right here, remember, when we are looking at regular confidence intervals, that part right there, that's the part where we have the standard deviation, the population and the sample standard deviation. But in this particular problem, we're not using the S or the lowercase sigma. We're not using population standard deviation and we're not using sample standard deviation. Instead, what we're using is something that relates to standard error. And this right here is basically what that looks like written out. You'll see it a little bit more clearly when I go through the example, but ultimately this number ends up being 0.25. And that's part of one of the things that they do for this particular problem and this formula. Again, there's a whole bunch of technical stuff that I can go into, but I'm not, for the sake of this class and for what you need it for, I'm not going to do that. But this just kind of gives you a little bit of information about the numerator of the stuff that goes underneath the square root. All right, so the first example, and you'll see it played out on the next page. But in this example, we know that we have a sample of 200 students, so that's our N. All right, and remember, in this particular problem for proportion, we don't necessarily have a sample mean. We don't have that sample mean. Instead, we have a sample proportion, and that's what this is right here. Okay, this is the sample proportion, and you'll see it on the next slide when I get to the actual problem where it's worked out. You'll see what I'm talking about. And in order to get that sample proportion, they took the proportion of students, because that's what that is. That is the proportion of students. All right. So this 60 students are 60 out of 200. That's our proportion. And remember, we're trying to find the confidence interval for a proportion. We're not finding the confidence interval for the mean. We are finding the confidence interval for the population proportion using the sample proportion. All right, so here's basically the problem itself. Here's the formula. So remember a few slides ago when I said that this number ends up being 0.25. Well, this is how. One of the things that they're not showing you here, but I'm going to do it real quick. They're not showing you the write out where this part is written out. So what this actually would be is, let's see here. So this would be 0.5, 1 minus 0.5. Because on that, a few slides ago, we were told that the P subscore U is always equal to 0.5. So if I wrote out all the stuff for this problem like I normally do, remember on the previous slide, we learned that the number in the sample was 200. We don't have a population, we don't have a sample mean, but we had that sample proportion. And remember, this was the 60 divided by 200. So the P subscore S is equal to let me do it the right way, 0.30, because the P, and this should be a lowercase p, but you get the point. The sample population, that's what that stands for. In this case, is 30, all right? The P subscore U is always equal to 0.5. And then the Z-score itself is equal to, in this case, we want a confidence interval for 95%. So we know that Z-score is going to be 1.96, just based on the things that we've talked about before. And you could look at that table and find that information. And then you can see where all of this has been plugged in. Except what they did, I write out every single step. I know you guys probably get tired of seeing me write out every single step, but I write out every single step. And this is why, because some people may be confused or could have been confused by the previous, a few slides ago, when it was talking about P ends up equaling 0.25. Some people need to see how you get to that. And this is how. So what was that number, 200? So then this basically would be what we have here. If we're going down, okay, 0.5, and then you basically multiply, because 1 minus 0.5 is going to be 0.5. Let me just show you that on the calculator real quick. So let's clear this out. So 1 minus 0.5, because all 0.5 that's half, that's 50%, is 0.5. You see, it looks like it never changed, but it did. It just comes out equal to 0.5. All right, so that's what you end up having here within the parentheses, divided by 1. And then it ultimately becomes the square root of, not 1, I'm sorry, 200. I don't know why I said 1. It ultimately becomes, let's let me show you using a calculator again. This ultimately becomes clear 0.5 times 0.5 ends up being 0.25, okay? 0.25 divided by 200. And then again, they've skipped a few steps. They're not showing you this step, but then this, they're not showing you what this number in here is before they do the square root, okay? So what I'm gonna do real quick is I'm gonna clear this out so that you can see what I'm talking about. If you need to write something down or whatever, I would suggest you do that now. Okay, so let's go ahead and look at that. Because remember, I said that before I cleared everything out, we ended up with 0.25. So 0.25 divided by 200, that gave us 0. There's 2 zeros and then a 125. So the step that's not shown right here, this is that step. So we'll just do this. 0.30 plus or minus 1.96. Okay. Let's go back to the calculator. Okay. And so we want the square root of, we want the square root of 0.00125. Ooh, there we go. Let me make sure that's what that number was. Yes, it was 2 zeros. Okay, and so if we then go and get the square root of that, we get 0.035355. Round up to the second decimal place, because there's a 5 after that 3, and anytime the number is 5 or above, we round up to the next number. That's how you get to the 0.4. So then it becomes this right here. So basically this becomes 0.30 plus or minus 1.96 multiplied by 0.04. Okay. And then that's how you end up with the rest of the information that you see down there at the bottom of the screen. But I just wanted to show you, rather than go through the entire problem, I just wanted to make sure you could see some of the additional steps, and you could see the different things written out, or the different aspects of the problem. You know, instead of the mean, we're looking at the proportion sample. All right, instead of looking at S or the oh, that's a funny looking one. Let me do this. So instead of X bar, we're looking at so for a regular confidence interval, we look at X bar before, so I'm going to put regular CI, and then for proportion CI, this is what we are looking at. Oh, that's a funny table, but you get the point. The population, the proportion sample, excuse me. We still look at a Z in both of them, so the Z corresponds. But instead of S or that little sigma, the standard deviation, we look at the PU 1 minus, 1 minus PU. Okay, I don't know what that line is, but it comes up there from time to time, and I don't know why. And I can't go back and just erase that. I don't think I can. Let me see. Oh, yes, I can. All right, so let's try that again, because I want you to be able to see how this works, to see this visually. So 1 minus P subscore U, okay? So those are, I guess you could say, the differences. The N is still the N. And so remember, when I write the problems out, this is all the information that I write out. Well, in a proportion confidence interval, this is how it I guess you could say, corresponds. Instead of looking at the sample mean, we're looking at the sample proportion. All right. So again, PS is equal to sample proportion. Okay. And we still look at the Z. Instead of looking at the standard deviation or the population or sample standard deviation, we look at this equation right here. All right. This P multiplied by 1 minus, there we go, 1 minus the P subscore U. And what that, I think, if I remember correctly, what that stands for is the standard error. Okay. All right, so we're going to go ahead and move on to the remaining information. This right here is basically another problem doing where they've calculated out the proportion. Again, they haven't done all of the steps. You know, if I were to practice this and write all of these out, you know, you would see where all of the various steps. Okay. But for the sake of time, because I know the first two presentations or lectures, I think the first one was 30 some odd minutes and the second one was probably close to 40. But right here, the key point of me showing you this is I want to make sure that you're not confused by the inclusion of percentage in this problem. So in this particular problem, they're asking about a percentage, right? Well, the deal here is percentages. When we get a percentage, all we're doing for a percentage is taking a proportion and multiplying it by 100. Okay, so percentages and proportions tell us information about the same number, and that the formula for the two is essentially similar. The what you do to get the percentage is you simply multiply the proportion by 100. So in this problem, 42%, this right here, can also be 0.42. Okay, so you do the same thing and you follow the same steps that you would follow for a proportion, and you end up with the outcomes. So once everything is said and done, when it comes to when you write this up, let me see, you multiply everything by let me see, let me get the confidence interval, and then I'll show you what I mean. So there we go. All right, so for this one, 0.42, because we still have it in proportion, 0.42 minus 0.0, move too fast, 0.42 subtract 0.04. So our first number is going to be, so what I'm going to do is this right here. I'm going to come up here with it. I'm going to do an arrow so you can see what I am referring to. All right, so the first part of our confidence interval is going to be in proportions. It would be 0.382, and so that I continue to practice what I preach, I tell you guys to double check your numbers. 0.46. Okay, so let's make sure that's going to be 0.46. So 0.42 plus 0.04, which is going to make that 0.46. Uh-oh. Okay, and all you do is you take these numbers and you multiply them by 100. And so, you know, just do this 100 and multiply by 100. That's going to give us 38. And that's going to give us 46. So in percentages, our confidence interval is 38% to 46%. And just so that you can see me do it, in case some of you are like, well, wait a minute, where did you get the 100 from? Remember, to turn a proportion into a percentage, you just multiply by 100. So that's how I got the 46, and you would do the same thing with the 38. I think the next slide probably shows you that. Yes, it shows you what I just did. All right. So what I literally just did by hand, that's what's on this particular page. Except for they're not saying that you multiply by 100. They're just, I think, this example kind of assumes that you know that, but basically to take that proportion and turn it back into a percentage, you multiply those numbers by 100, and you see this is essentially that same thing, but instead of the 0.42 plus or minus 0.04, 0.04, it's 42% plus 4%, and then you get the same thing that I got. Okay, but when it's written out, it's written out a little bit different. Notice that instead of the proportion, the PU, instead of that, I think that's what that is. Instead of that symbol right there, when we're using a regular confidence interval, we use the sign for the population mean. So we use that little thing right there. Okay, whatever. You get the point. I can't, again, as I said before, I have a hard time drawing that one. Then the way you would interpret this when you turn that proportion into a percentage, we estimate the population value is greater than or equal to 38% and less, 38% and less than or equal to 46%. Oh, excuse me, I missed a word. I knew something sounded really strange. I missed a word when I said that. So we estimate the population value is greater than or equal to 38% or less than or equal to 46%. Okay. So that's essentially what it comes down to when we look at proportions, and then taking those proportions and turning them back into a percentage. Okay. So what we have here, just basically when you're interpreting a confidence interval, there's information that you must present. The point of calculating the confidence interval is to learn the information listed in the slide above. So this is, the information you need in terms of to calculate, but there's certain things that you need to have when you are interpreting a confidence interval and you are writing a sentence. You need to basically let the readers know about the sample size. You need to let them know about the interval itself. Okay. Refer back to the population that you are estimating. And then you definitely need to include information about the confidence level, the 95%, the 90%, whatever it is. You either write that as alpha, or you can say, we have 95% confidence that the sample mean or population mean lies between an interval of blah, 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 blah. Okay. Use the examples that I've given you here when it came to the interpretation for the different types of problems. Use that to help guide you when you're writing this stuff up, because you will have to interpret some of this when you work on some problems and different things like that. All right, this is these are some more examples. Using that information that was on the previous slide, these examples demonstrate how you need to write that up. So what, you may want to do, hint, hint, is have this in a spot that you can refer back to very easily. Like, don't just look at this slide and say, oh, okay, that's just some extra information. No, this is how you are going to this is one of the ways you'll want to write that information out. So this is from, I think this is this may be the second example that I did. Yeah, I think this is the second example. But basically, you have the confidence interval, and then here's the interpretation below. So based on a sample of 200 community residents, we are 95% confident that the estimated average income for the entire community is between $44,982.45 and $45,017.55. That what you see right there in quotes, as well as the confidence interval that appears right above it, that's the way you need to write that information up. Okay, and then you can see the same thing below for the proportion. Based on a sample of 200 college students, we are 95% confident that the estimated proportion of students that had missed one day of class due to illness last year is between 0.22 and 0.38, or between 22% and 38%. Okay. All right, so what we pretty much have moving forward is just information, kind of like a recap. After this, pretty much after this slide, it's just kind of a recap, summing up some of the information that I've already gone over. But one of the things to keep in mind is that because the researcher is the one who controls the level of risk, he or she can determine how wide they want the interval to be. The width of the interval, the confidence interval, can be increased or decreased by changing the confidence level. Okay, so that's what you see here. So if you take that confidence level, let me highlight this. So here's the confidence level. Okay, that's what these numbers are right here. And you can change the width based on the confidence level. Okay, so if I want my interval to become wider, I can increase my confidence level from 95% to 99%. And if you notice, the interval width for 95% is $35.08. But if I make that width even larger, it's $59.42. But with that one, I'm 99.99% certain that my population, or whatever, my population parameter is going to fall in that interval. That salary that this example is based on, it's going to fall within that interval. Okay, so you're basically increasing the chances of being correct. Now, you also have situations where when the sample size increases, the width of the interval decreases. So what ends up happening is larger samples provide more precise estimates. So as you can see right here, you have a sample where your N starts at 100, and you can see your interval width is $78.80. But by the time you get all the way down to 10,000, that sample, that interval width has narrowed considerably. All right, this right here, actually, this isn't, don't worry about this. I think this was just me demonstrating and showing you, different techniques and different things like that, but don't worry about the slide. It's actually not even supposed to be there. All right, so this particular slide right here, this is just kind of summing up the different formulas. So one of the things I would do if I were you, just like earlier, I told you those symbols and different things like that, you might want to, wherever you write your information or keep your notes. I know some of you keep notebooks that have the formulas. Some of you print some of the stuff off, and you have a little booklet that you've made where it has the formulas or whatnot. Me, I was one of those where I would do that, but I would also have something where I would handwrite everything. I'm one of these people that I'm visual and I have to write stuff out. That's how I remember things. Whatever method you use, whether it's index cards, whatever method you use, I would definitely write these out. Okay. I would have this table or this chart. It appears somewhere in your book. I don't remember where, but I would have this so that you know what sample statistic is being used with each type of problem. Okay, you know that for confidence intervals for the first two, we use the sample mean, but the formula changes up when we know versus when we don't know the population standard deviation. And then for a proportion, the sample is not sample, but for proportion or the sample proportion, the formula that we use differs from the formula that we use when we are doing a confidence interval and the sample statistic is a mean. So definitely get these formulas, put them on an index card, put them in your notebook, whatever it is you use to collect your information and take notes. And have these formulas in a handy spot because you will need them, and you'll need something to help you remember when you use when to use each formula. Okay. And on that note, that actually concludes the lecture for part 3 of chapter 7. As always, as I say with everything, if you have questions, please feel free and do not hesitate to reach out. Catch me during my office hours, or which are posted in Canvas, on the syllabus page in Canvas. You can catch me during my office hours. You can send me an email, or you can post a question in the Ask the Instructor discussion board, whatever you need to do. If you need clarification on something, you guys know the routine. Okay, on that note, have a nice day. Take care, and I will be in touch.